I was born here, raised here. What we have here, what we call home, the reservation is roughly 650,000 acres. It's our duty, we're mandated to make sure that we do everything possible within our power to safeguard it. We want to protect it. We want to take care of it. We want it to, like anybody, we want it to outlive us and be here for our grandkids and great-grandkids. So World Wildlife Fund presented us with an opportunity, and we took it.
World Wildlife Fund nearly always works in partnerships. We don't own land, so everywhere we do work is in concert with the folks that share the same mission that we do to restore nature, restore wildlife that live in that habitat. We're contributing, hopefully, up to 100 black-footed ferrets to the 3,000 needed for delisting this endangered species from the Threatened Endangered Species Act. That's huge.
We're looking at recovery, reintroducing the black-footed ferret, which has been extirpated from this area, and looking at prairie dog colony size, and that'll give us a good indication of how many black-footed ferret can be supported by the landscape.
The question came about after many months and years of monitoring prairie dog habitat. Is there a better way to do this? Can we do it more quickly, more efficiently?
The Topcon Mavinci Sirius Pro really provides that simple turnkey solution to data collection.
This project is very innovative in the fact that no technology like this has been used on tribal lands.
The Topcon UAS is essentially a flying rover. You have an RTK base setup, and then you use the plane in lieu of the rover, so it allows you to cover much more area in a much shorter amount of time.
So last summer was the first time we did a comprehensive assessment of how many prairie dogs were across the reservation itself, and it took up to 4 individuals, 2 to 4 individuals on any given day, pretty much all summer.
You can put it together with a pretty standard set of tools, a screwdriver set, a small wrench. We would typically run some safety checks, and then we would launch the plane, which would follow a preset flight plan that we develop.
The aircraft basically flies itself. I mean, we launch it and we land it, but in between, there's really no human interaction.
First thing I did was I looked out at the prairie dogs, see what they did, because it looked to me like a big bird, a big eagle or hawk flying around, circling around up there when it was flying. And I couldn't believe how quiet it was, how far it flew away from the base they had there.
It's able to handle very high winds. The images, which ultimately lead to your data, are extremely good, better than most anything that we found.
To fly in this open landscape with the wind and the elevation and the variables here, and having that flight line that was planned, and you look at the computer and that drone is collecting every point that it needs to and doing everything that's supposed to, that's the kind of accuracy that's really hard to get. And here this thing is, it's doing it like this. It's huge.
The photos are taken by GPS position, not by time. Most people will tell you it's great because theirs takes a shot every half second. The problem with that is on a windy day, when you're flying into the wind, you're going to have it go click, 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 click. When it goes the other way, it'll go click, click. You get holes in the data. This takes it by GPS position, so it's always consistent, it's always in the right spot, and you don't miss data.
So as soon as we land the plane, we download the flight log and the photo log information, the whole path that it actually flew, the information about the positions of all the images that were taken, the orientations of the photos.
We can typically collect 30 to 40 million points, somewhere in the neighborhood of 40 minutes of flight time.
You can have the complete 3D model and point clouds by the end of the day processed, and you can start doing your job.
These types of platforms make data accessible for researchers in ways that just haven't been possible before.
Well, I mean, how often do you see tribal, conservation, university, private sector coming together to do a good project like this? So this is quite exciting, and as Chris said, we're making history here.
Success in conservation is rarely achieved alone. Partnerships are key. And this has been a really important and valuable one that I hope we can continue.
It's really been a great experience to help make their projects go faster, easier, safer.
What are we doing? We're basically mapping a prairie dog town. I don't know that piece, although very important, spells the whole thing out. I think the bigger picture is that we've all come together to try to preserve what we have here, and that regardless if we were going after buffalo to photograph or map prairie dog towns, the fact that we could come together with that piece of technology and put it to good use, I think is the key.